Okay, so this will be my Gen 2 CO2 preheater. I redesigned and shrunk down the control box a little bit using smaller LEDs and a slightly smaller box anyways for the control components. Also where the fuse is inside that control box as well for overcurrent protection for the circuit. Um, Switched from plastic to a metal enclosure for the controller. Also, one of the major things I did was I changed the heating element that I'm using to a more efficient, higher, and quicker responding PTC, positive temperature coefficient heater, operating on 12 volts. This particular device is well suited for this application as it automatically adjusts its electrical resistance as temperature changes. Unlike conventional heaters, this particular device, this PTC heater, increases resistance dramatically as it reaches its designed or desired temperature threshold, naturally limiting the power consumption and preventing overheating. In addition to that, it's kind of perfect for simple circuits like this that's going to be controlled by a 40 degrees Celsius, 104 degree Fahrenheit thermal switch. Same thermal switch that I used on the first CO2 preheater. Um, it's not so pretty to look at the moment. I had to come up with something inexpensive way to um, get that heater right there, that PTC heater, up against the aluminum Umarex CO2 housing. So for now, I just opted to go with metal wire, which seems to be working just fine. It's holding it in there, holding it flush up against the aluminum cylinder, which will act like a heat sink and draw the heat away from the device into the chamber where the CO2, 12 gram CO2, will reside. For today's testing, there's no CO2 in there. I'm just going to have a meat thermometer in there, which is kind of resting on the top near the thermal switch. So I'll get a good, decent idea what the internal temperature would be. Um, Also, I'll be using a Amazon special um, laser to take various readings of the switch, the heating element, the PTC heater, ceramic heater, and also confirming the cylinder temperature as it heats up and cycles through. And we'll go ahead and start the first test now and see how it cycles. In theory, the way this should work is it comes up to 40 degrees Celsius at the thermal switch here. Thermal switch should trip open, cutting off 12 volts to the heater and also cutting off the red heat active LED that will be illuminating during the heat cycle. I also have a green 12 volt LED that gives us an indication of this presence of 12 volts. Also lets me know whether the fuse is good or not, or has blown. The power comes in from the lithium ion battery pack in the back here through this cable that runs through the rail and down through the back into the control box. From there, it goes into the switch, the line side of the switch. I'm sorry, incorrect. First, it goes through the fuse, the 4 amp fuse. Then it goes to the line side of the switch, and then out of the load side of the switch, where I also have the positive cable from the red LED, the heater LED going. It taps in there. Then from there, it goes out of the control unit and up here to the thermal switch. That's the basic operating. It's all controlled automatically through this thermal switch. It also serves as a safety device. However, the nature of the PTC, getting tongue-tied, PTC ceramic heater is that it's naturally current limiting. So as it gets warmer, it changes its internal impedance of the circuit, which acts like a resistor and reduces the power consumption, and also prevents it from reaching an overheat status. So let me turn on the thermometer here. The thermometer currently in there says it's 77. The table, I turn this on. The work table here shows 73. 73 here. The control box is showing about 73, 74. It's kind of warm in the house. The on and off valve is showing 75. The Umarex aluminum cylinder for the two 12-gram cartridges is showing 75. It's open air, the cap's not on the back, and there's no CO2 in there. This way I can take a reading. So we're about 75 to 77 degrees right now. First thing I'm going to do is I'll go ahead and turn the switch on. Notice the 12 volt green LED is illuminating, showing that there is 12 volts available, and that the fuse internal to the control box is good. The red heating LED is also illuminating, indicating that the thermal switch is indeed closed. And our PTC positive temperature coefficient heater is starting to warm up. It's going to get really hot. It's going to probably go, I saw up to about 225 degrees Fahrenheit. And I think it kind of plateaus at that point, or peaks at that point. Again, the aluminum housing acting as a heat sink should transfer heat into ultimately where the CO2 will be, in order to increase CO2 pressure, warm the cartridges, and increase the operating pressure. The Umarex cylinder is sitting at about 143 right now. Circuit is we still have the red heat active circuit on. The meat thermometer showing 106 degrees internal, inside at the top, approximately where that thermal switch is glued down to. And this is all very crude at this point, using what I had available. It'll need to be cleaned up and cosmetically make it look a little bit better. But this is second generation reduced control box size and improved heater, now using a ceramic PTC heater, which, okay, so that's the first cycle, half cycle. It has reached 40 degrees Celsius at the thermal switch, and the heat, calling for heat or heat active LED, has kicked off. So the circuit is now open. The heater no longer has 12 volts applied, and the temperature is bleeding down now. Should take about 2 minutes or so, and it should cycle back on and then repeat cycling every 2 minutes. On, off, on, off. At least at the ambient temperature in this room. I suspect if it was much colder, you may see it staying on longer than it is now. So for now, I got a baseline on this. We are still open circuit. Temperature is still dropping. It's about 99 to 100 degrees at the top of the Umarex cylinder on the outside. The internal temperature is dropping. It's still about, it's about 106, but it's coming down slowly. The heating element, the PTC heating element, temperature has dropped considerably. It's about 74 degrees, it looks like. Well, maybe 80. Gotta hold this thing steady. Yep, coming down. Everything's coming down. The outside of the Umarex cylinder is sitting at about, I can hold this thing steady. Well, I guess depending on, oh, it just kicked back on. I didn't even catch the clicking sound, but it's the red heat LED is illuminating again. So that's one complete cycle from on to off, back to on again. See if I can catch it next time. Some other tests that I ran first off camera, it looked like it was cycling every 2 minutes, which is a considerable improvement from the previous design using the other film type heater. Oh, okay. So now it just kicked off again, went open circuit. The thermal switch is once again open circuit. What do we have here? Okay, we're sitting at about 130 on the outside of the top of the Umarex cylinder. 115 degrees internally. On the meat thermometer. I may actually have to get a lower rated, like a 35C maybe. I don't know, because once that cylinder is closed and capped off at the end, I don't want to exceed 120 degrees if I can help it internally there. Actually, I'm totally fine with 100, 105, 110. I don't want to I don't want to cook these things off. It wasn't a problem last time, but last time I didn't have this sort of, this type of heating element. It wasn't nearly as efficient, especially when it was cold, but we'll test again and see what it does down in the basement where it's 60 degrees. It's pretty warm in the house, in the office. It's like 74 in here. Well, 72 to 74, but almost everything in here. Well, make a liar out of me. It's 71. Okay, 72. I don't know. This Amazon thermometer, who knows how accurate this thing is. All right, so it kicked off again. It seems to be louder when it switches to its closed position than it is when it kicks open. So it's open circuit again, or the heater is off. Let me just see what we're doing here. Oop, and this thing timed out, so let me turn this back on. All right, so we're at 103 inside. So this might be working out fine. Maybe it gets up as high as, with it cycling every 2 minutes, maybe it gets up to 115, 120, and then drops back down and just keeps cycling back and forth every 2 minutes, minute 30, 2 minutes. I mean, this whole video right now is about 14, going on 14 and a half minutes. I did a bunch of talk. Oh, she just turned on again, calling for heat. Now, see, I could hear that. It's doubtful that it's going to show up in the video, the audio, but I could hear a little click, faint click. Not hearing it when it clicks open. All right, so we are heating again. Temperature's going up. 105. Looks like my max temperature captured on this thermometer is showing 143. All right, it just kicked off again. I heard it that time. Maybe I was just talking too much before and couldn't hear it. So, I mean, what's that? I think it's just around 2 minutes. It's 115 and dropping, slowly dropping. So that's what, third or fourth time it's cycled. I'm not going to make this video too long. We'll let it cycle one more time, and I think we'll all get the point here. It seems to be working just fine. It's cycling a lot faster. We'll have to see how it does with some colder ambient temperatures down in the basement where I usually do my shooting, in the hallway down there. We'll let it cycle on and off one more time, and then I'm going to stop this video. I think the video is representing the circuit operation just fine. Again, you know, this is my second prototype circuit. It's not super pretty. I got to come up with a better thing than this metal wire. I'll probably see if I can tap some threads into either side of these scope mounts here, and maybe get a small metal bar that I can put across and just screw to it to kind of sandwich in that that ceramic PTC heater. And then as far as the thermal switch, right now I'm using some black hot glue. It's the only thing I could come up with at the moment. I can't drill into the Umarex cylinder, CO2 cylinder, for obvious reasons. So maybe I can do something kind of like what I plan on doing with the heating element. Maybe I can, tap some threads. I'll get a tap and die set, tap some threads in here, and maybe I can do something similar. And possibly, if not, then maybe we'll just continue to use the hot glue. It seems to be holding okay. I tried hot glue in this first, but the hot glue this thing got so freaking hot. It was just, even though they say the hot glue is good to like 300 degrees, nah, this thing started to smoke it after about a minute or two, and it was softening up, and that wasn't going to work. So the only thing I could think of right now I had on hand is some of this metal twine. So, and that's holding it in there pretty good. That's probably hot to, you don't want to touch this thing when it's going, I'll tell you that. Right now, 76, we can touch it now. Yeah. Oop, just kick back on. All right, kick back on. Let's watch the temperature climb. So I had my finger on it 10 seconds ago. So this definitely performs much, much faster. It's more efficient. I'm not blowing any fuse. I mean, it's a 4-amp fuse. The battery pack, the lithium-ion battery pack, seems to be holding up just fine. I think it's going to have the capacity I need to, I figure if it's sized properly, hopefully it'll provide operation for an hour or two. Not that, you probably won't even need that long. Oh, see, now I didn't hear it, but the circuit just opened. All right, so that's like 5 or 6 cycles. I think that's good enough to get the point across. Again, this is what I'm calling Gen 2 CO2 Pre-Heater, using the upgraded heating element, the PTC, which is a positive temperature coefficient heater, ceramic based, with the ability to self-regulate, changing its internal impedance as it heats up. And seems to be working good. All right. We'll have to do a test downstairs and see how she shoots next. See what kind of, I'll have to do the next test will be with CO2 in it and see what gains we get in pressure.